Oh, hello, my name is Norbert Lechner and I'm working as a sports scientist and economist in the prevention department of the Austrian Workers' Compensation Board. I would say we are more practitioners than scientists and supporting companies all over the country in their legal order to do prevention. Requests for economists come from all industries, like logistics of course, shoveling work, cleaning work, pushing and pulling, repetitive tasks, operating machines or surgery. You see an arm supporting exoskeleton. And therefore we have in recent years established various digital technologies in our daily work in ergonomics to support companies such as the software EMA for digital workplace design and simulation, or the computer tomography. You will hear about that in the afternoon. From prediction of movement with the 3D musculoskeletal computer model. Eye tracking a little bit, diverse force measurement systems, the thermography as an imaging method for displaying the surface temperature of objects, several motion capture systems, and as well extended reality, what I will talk now. So extended reality, probably you know, is a generic term for virtual, augmented, and mixed reality. So the VR is an artificially generated environment, fully immersive. The augmented reality is a computer-assisted extension of reality perception, and in the mixed reality, real and virtual objects interact. In our prevention department, we have already some applications, like the safe commission of a stacker. On the right side, you see the safe implementation of forestry work, including emergency and evacuation scenarios. Then you see we don't need the sound. Yeah, it's no problem. So Intercare is a training tool for home care to make a safe environment without fall and tripping hazards. And on the right you see intubation and evacuation of a hospital. So, extended reality and ergonomics. Before I started to work with XR 2 years ago, the questions I asked myself, so how can XR be used for consulting and training of employees in ergonomics? And which applications can be used to reach the broadest possible target audience? Because I'm really in companies all over the country in all different branches. So extended reality for workplace design, so address C employers is not the main focus of the following project. Project partner for developing the first ideas were institutes of creative media technologies and health sciences of the University of St. Pölten. The first deployments were a warehouse, a room for the training of manual load handling, a virtual drilling machine for training of workplace design, and a scaffold with the idea for training of coordination and balance with the aim to prevent slip and fall. Rooms were programmed compatible with a motion capture system. That means in every room a worker has to execute a task which is instructed by a trainer. Here it was lifting boxes out of a shelf, and the operator, the trainer, can start and stop the task, could give auditive and visible feedback, or could repeat the task. It's very nice, but there are problems with the immersion in the VR. So what about the reality content? There's no haptic feedback, no abstract interaction with the environment, a body is missing. So we proceeded with integrating real objects in the VR, with scanning the real object with LiDAR scan technology, defined and tracked it with Vive trackers and matched the coordinates. Additionally, we pre-recorded different training relevant movements with a full body motion capture suite and visualized as an avatar, which was implemented into the program. So at the end, the exercise was to lift loads in different tasks, and the operator can give the subject individual feedback with recording avatars showing them fast in slow motion and in 360 degrees feed. In another project, the Ergonomics tools were developed into the augmented reality. That means you see the real load, lift it, and get displayed life-sized avatars in the real world as feedback. The following evaluation study with the University of St. Pölten and the Technical University of Vienna, they tried to compare the augmented reality and the virtual reality trainings tool at the warehouse. With workers of a Spar headquarter in Austria. So we had 18 subjects which had to lift a 15 kilogram box with vegetables and drop it off frontal and 90 degrees offset. With two groups, the first with no device and with VR, the second with no device and with AR. Movement analysis was done with video recording and software-based evaluation in the software Ergomaps. So it's a classic use of deep learning. Videos were played in Ergomaps and the algorithm extracted the background, and the software filters out the human, places a skeleton over the human, and recognizes joints and calculates the movements. The evaluation software is already fed with 200 videos and different images and continue learning what is good, what is bad. To evaluate the human-centered perspective, a questionnaire was administered after each test scenario. So the Net Promoter Score is calculated by subtracting the number of detractors from the number of promoters. In this case, it shows poor results for both scenarios, so minus 38 for the AR scenario, minus 11 for the VR scenario. The higher the NPS, the more likely the training is to be recommended. The recorded videos were analyzed using Ergomaps. So the program evaluated the videos frame by frame and determined the worst and the most critical ruler score for each video. So subsequently, the ruler score, ruler is an ergonomic assessment, I forgot to say, were compared person by person to see if the training caused a change in the critical ruler score for each individual. So for frontal lifting, an improvement was achieved in VR in 50% of the cases in the VR. You see the stoop angles for a no device condition. It seemed very widely but generally distributed around the median of the group. Stoop angles in the VR condition are more concentrated in comparison to the no device condition, indicating that individuals tend to stoop more in the virtual reality. The stoop angles for the AR condition are more narrowly distributed and centered around the lower median compared to both no device and VR. The maximum knee angles for no device condition vary, but generally cluster around the median. So the spread is moderate with a few outliers. The maximum knee angles in the VR condition are more tightly clustered around the higher median compared to the no device condition, suggesting a more consistent performance. So the Net Promoter Score results were poor for both scenarios, minus 38 and minus 11 for VR, indicating a low likelihood of training recommendation. The analysis of the software Ergomaps shows frontal lifting showed 50% immediate improvement. Lateral lifting results were mixed. 33% improved, but 25 performed worst post-AR. And the coach's feedback, both systems can be deployed, but have advantages and disadvantages with potential for further improvement. So individuals exhibit the highest stoop angles in the VR condition. AR condition results in lower stoop angles compared to both VR and no device conditions. And overall, the data suggests that while VR tends to encourage a higher knee angle, AR may still provide benefits with a more consistent performance compared to having no device. But both VR and AR show promise, but also indicate areas for potential improvement. So I know maybe it's a poor and a small study, but the whole process and development behind to get a new trainings tool to go into the companies, I think this has a lot of potential for the future. Thank you very much.